Let's do another example for solving separable differential equations. We have x cubed times y prime plus 4 times y squared equals 0. Remember, you know it's a differential equation if, of course, it has an equal sign, and it also contains a derivative, and it adds to the challenge the fact that it contains both a y and a y prime. So we're going to do the same thing as the last example. For example 2, first we're going to find a general equation for y, meaning getting y by itself. And then we're going to find a particular solution at this particular point, 1, 2. Now I did want to mention, what makes a differential equation separable? Well, it means that you can separate the y's and dy's from the x's and dx's. Sometimes that's not the case, and that's when you take a course like differential equations, where you have different types of differential equations that aren't separable. But we're just going to focus on the separable ones for now. Step 1 is to convert y prime to dy dx. So again, we do that because we have to get the y's and dy's on one side and the dx's and x's on the other. So I'm just going to convert this y prime to dy dx for this particular step. Step 2 is to separate the y's and dy's from the x's and dx's. That's what makes it separable. So the first thing I'm going to do is move the minus 4y squared to the other side. And now we have negative 4y squared on one side and x cubed times dy dx on the left. So now what I want to do, as you can see, is move this dy to the right. The way to do that is to divide both sides by dy, or multiply by 1 over dy. So if I multiply the left by 1 over dy, I have to multiply the right by 1 over dy. That will leave me with basically canceling these dy's will cancel, and I'll be left with x cubed over dx on the left, and on the right I'll be left with negative 4y squared over dy. So that completes that step. I've gotten all my dx's on the left and my dy's on the right. Now again, I said before that I usually try to put the y's on the left and the x's on the right, but it won't matter in this particular case. It's easier just to do it this way. So again, this is what makes this equation separable. I'm going to write that word down here. If you're able to do this and get the x's and dx's on one side and the y's and dy's on the other, that's called a separable differential equation. If you're not able to do that, it's called non-separable, which is a totally different lesson. Step 3, put in the form gy dy f of x dx. So here's the problem. I went too far here. Let's go backwards here a little bit. Okay. The problem is my dx's and dy's are on the bottom. So in effect, what I have to do is just flip these. Okay, because the dx's and dy's need to be on top. And it'll do that, just raise both sides to the negative first power, or take the reciprocal of both sides. Remember, we can do that because if two things are equal, then the reciprocals are equal. So that flips them, puts the dx up here and the dy up here, and then x cubed on the bottom, negative 4y squared on the bottom. And then we want to put it in the form g of y dy and f of x dx. So basically, I'm going to move this x cubed out. That's going to be my f, or my f of x, right here. And then I'm going to move this out too and put it under 1, and that's going to be my g of y. Okay? Okay, so now that I've done that, I do that so that I can easily integrate this, right? So I can easily integrate 1 over x cubed, and I can easily integrate 1 over negative 4y squared. Remember, when I take the antiderivative, I want to put my plus c on my dx side. So step 4 is to integrate both sides. I'm going to integrate the left, I'm going to integrate the right. In fact, I will take the left and re-put it in terms of a power, so I can use the reverse power rule. Same for the right side. I can rewrite that. I can pull the negative 1/4 out, and I can rewrite y squared as y to the negative 2 to make it easier to take the antiderivative of. So the antiderivative of y to the negative 2, add 1, so it's y to the negative 1. Take that and make that the coefficient. Over here on the left, antiderivative of negative 3, add 1 to that, you get negative 2. Divide by that number to get negative 2 on the bottom. And then remember, always put the plus c on the side with the x's. So put the plus c there, and over here on the right, this can simplify because I have two negatives, so it's going to be 1/4 y to the negative 1. Step 5 is to get y by itself. In fact, I might have shown that. No, I didn't. Okay. I'm surprised I didn't show that. Let's go ahead and just simplify this even more. So this will become a negative 1/2 x to the negative 2 plus c. And on the right, two negatives, we're going to end up with 1/4 y to the negative 1. So for our next step, we want to get the y by itself. There's a lot of different ways to do that. For this particular example, what I'm going to do is just rewrite it as 1/4y. So basically, whoops, again, I done to the wrong slide. I'm going to write this as 1/4y. I'm going to write this as, in fact, I'll just show it on this slide. I like showing more work. So this is going to become negative 1/2x squared plus c is equal to 1/4y. Okay, so now to get y by itself, you can see there's going to need to be some cross multiplication here. So what I will do is I will multiply both sides by 4y, which is what I did right here. That way, I can cancel my 4y's here, and now I'm going to have 4y on the left. Now you might say, well, you're trying to get y by itself. Yeah, but the only way to do that is to get the y out of the bottom first. So now you can see what you can do is you can basically move the 4 over, so 4y becomes y times 4, and then divide the entire right side. Now that these canceled, I just have 1. Now I can divide the entire side by all of this stuff right here. So I'm going to be dividing by 4 times negative 1/2 x to the negative 2 plus c, and that will give me the y by itself. So in fact, over here, I had simplified this, but you won't have to do that. You can just leave the x to the negative 2 like it is, and then divide to get y by itself. Okay, so that's what we're going to do next, divide both sides by all of this stuff. Now, I guess before I did that, you can distribute the 4 in to both of those things in the parentheses. So 4 times negative 1/2 is negative 2. 4 times c is 4c. I guess I did it a different way. You can just go ahead and divide if you want, but we'll go ahead and do it the way I did it before. So distribute that and then divide both sides by that. So for this particular example, again, I'm just dividing both sides to get y by itself, and now I have y equals 1 over negative 2x to the negative 2 plus 4c. And now the next thing we're going to do is we want to get this x to the negative 2. We want to get this out of the denominator. You really can't have any negative exponents in your answer, even though we have y by itself. We want to simplify that. So I multiplied the top and bottom by negative x to the negative 2. That will get rid of this negative here. I'm sorry, negative x to the positive 2. It will get rid of this negative here, and the x squared and the x to the negative 2 will cancel each other. So this and this will cancel each other out, and it'll just be negative times negative 2, which is positive 2. But I also have to distribute that to the right-hand side. So it ends up being negative 4c times x squared. On top, it's just going to become negative x squared. So again, I'm doing that to cancel out this negative exponent. So now I've gotten y by itself, and there's one more step. If we talked about earlier, this is just an arbitrary constant. Minus 4c is the same as a constant number, right? Just suppose that I plugged in 2 here, I'd get negative 8, which is still a constant. So just change this to just plus c. Okay? And that's exactly what we're going to do. So the negative 4c becomes just plus c, and now I've gotten y by itself, and I can check that off. So we have y equals negative x squared on top over 2 plus c x squared on the bottom. So we've tackled part 1, which is to find a general equation for y, and we've simplified it, right? Now part 2 is to find a particular solution. So now that we find this, basically will give us our slope field, right? Our entire slope field will give us all those different curves. This will give us a bunch of different curves for our differential equation. Okay, so we started out with a complicated differential equation. You can imagine the slope field is pretty complex, right? Now we're going to find a particular equation particular solution curve that passes through the point 1, comma 2. So basically, we're going to be plugging in 1 for x and 2 for y and solving for c. Okay, so every time there's a y, I'm replacing it with 2. Every time there's an x, I'm replacing it with 1. Okay, and then now we can solve for c. And I'm going to go ahead and do this by hand. So we're going to get 2 equals, top is going to be negative 1 over 2 plus c, because 1 squared is 1. Now what I can do is cross multiply. So on the left, I'm going to get negative 1. On the right, I'm going to get equals 2 times 2 plus c. So negative 1 equals, well, actually the best thing to do from there is just divide both sides by 2. I was going to multiply the 2 out, but I don't need to do that. So divide both sides by 2, and we're going to get negative 1/2. My 2's are terrible. I apologize for that. Equals 2 plus c. And now all I have to do, let's switch colors here, is subtract both sides by 2. So negative 1/2 minus 2 is negative 2 halves. Negative 2.5, which is negative 5 halves. Okay, and in fact, because of the fact that it's in the denominator, I'm going to write c is equal to negative 2.5. So now all we have to do is take that c value and plug it back into our general solution, and we'll be done. Okay, for our final step 8, we write an equation for the particular solution. So you take that c value you just solved for, and you plug it in for c, and this is the equation: y equals negative x squared over 2 minus 2.5x squared. Again, what that gives you is the curve that passes through the point 1, 2 on this particular slope field for x cubed y prime plus 4y squared equals 0. That equation will give you the curve that passes through 1, comma 2 for this particular differential equation. That's it for this particular example. If you have any other questions about it, let me know.